So as promised you in the last class, I will go to the arrays. But before going to the arrays, I would also like to discuss a little bit more about control structures, specifically for the nested loops and a couple of very important statements which are called break and continue statement, and then a go to statement. After this, I'll go to the arrays. So let us begin with the nested loop first. So, what is a nested loop? Nested loop is a loop inside the loop, inside the loop, inside the loop, because there is a nest of the loop. You all understand nest, right? A bird's nest, which is fibers inside the fibers, inside the fibers, inside the fibers, and so on. So, similarly, nested loop means a loop within a loop or within a loop. So there can be several different loops. So officially, I can say that a nested loop is a loop inside the body of another loop. What is the example? So, for example, I'm dealing with matrices, let's say, and I have a 3 by 3 matrix. There are three rows and three columns. So I'll say, okay, for row is equal to 1 and condition when until row is less than equal to 3, and each time I increase the counter row as 1. So 1, 2, 3, it will take three values. Within that, this is for each row. For each row, there is a column. So there is a column y equals to 1, column less than equal to 3, column plus plus, and then I multiply this row multiplied by column. So this is a multiplication of two matrices, which are 3 by 3 matrices. So and I put output row multiplied by column and end of line. So it will give me a sort of a multiplied matrix. So what does inner loop goes? Inner loop goes through all its repetitions for each repetition of outer loop. So this you have to understand. For one value of row equals to 1, the inner loop will repeat for all the values of column. So for row equals to 1, it will go for column 1, 2, 3. Then when column is greater than 3, it will go back here. Then row becomes 2 because row plus plus. For row equals to 2, I'll again go with column 1, 2, 3. Then row equals to 3, I'll again go column 1, 2, 3. So my loop will run 9 times, 3 for each of these 3 values. And the inner loop repetitions complete sooner than the outer loop. So first the inner loop will be completed, then it will go for the outer loop. Total number of repetitions for inner loop will be the product of the number of repetitions of the two loops. So in this case, 3 repetitions multiplied by 3 repetitions is 9 repetitions. So in this example, inner loop will repeat 9 times. Now, these are in fact the question of a choice. It's not necessary. It's a question of what language do you choose, or what words do you choose in a language to convey your meaning. So here also for loops, it depends on a particular programmer whether you want to use a for loop or a while loop or a do while loop. They all can be interchanged with each other. So for example, any for loop can be converted into a while loop, and a while loop can be converted into a for loop. But there are some standard guidelines to choose a loop, but it's not necessary that you follow them. But I'm just mentioning it for your convenience. So if the loop is a simple counter control loop, you know beforehand how many times you have to want to do this looping, then the for loop is a natural choice because you already know. So and everything is defined within the parenthesis against the for condition, so you know what you are doing. Now if the loop is an event controlled loop, then whose body should execute at least once. Sometimes you need that your body should execute at least once. Then a do while will be preferred. And if it is a loop, if it is again an event control loop and nothing is known about the first execution, you don't know whether you want to do the execution once or not, then you use a while loop. So do while it should be the least used loop, then while, and if you know the all the number of iterations, then the for loop is a natural choice. But people say if you have doubt, always go for a while loop because there is no precondition for a while loop. You can even go for a simple counter control. You can also go for, even if it has to be executed once, then also you can use while loop and put a condition like that. So this is the uh, it's a general loop to be used. Now, in one of the example in the last class, probably I used, yeah, I think with the switch statement, I used the word the keyword called break. So today I'll differentiate between break and continue statement because they are a very important keywords to used in the control structures. So break and continue are very important keywords. So the C++ provides these statements to uh, control the control structure basically. So even when you are controlling through the flow of control structure, even within that condition, if you want, sometimes you want that, okay, now want to come out of this, even if that condition is satisfied, but I want to come out, then in those conditions, depending on what you require, you need to use break and continue statements. What does the break statement do? When it is used in a while, for, or a do while, or switch, as we already saw in the switch statement, it causes an immediate exit from that statement. Remember, it just comes out of that body. It is an exit from that particular statement body. So if the break is executed in a loop which is nested inside another loop, then the control will exit the inner loop but not the outer loop. So break only works for that particular part of the statement body where it is located within those curly brackets. So control exits only the inner loop but not the outer loop. And the syntax is straightforward, just break and a semicolon. Similarly, continue also the same in syntax, continue and the semicolon. So let's see some example of the break which we have already seen. Say, suppose you have a for loop where none of these preconditions are given, no initialization, no condition, and no updation. But initialization has been done here, and conditions has been done here, updation has been done here. Has been done here. And if you don't do anything, then it is a forever loop. And I'm saying if marks equals to -1, then break. So I'm giving that condition here. Since condition is, if I didn't give it within the for loop, I would have given here marks equals 1. But if I have not given, I've given it like this, and to break from the loop. So from this for loop will be broken, and the computer's control will come out here. Similarly, I can use this in a while statement also. While 1, now this is an infinite loop. I am saying 1, so 1 is always true. So this condition will always be true. Whatever I do, it will always be true. So how do I break from this? Again, I put marks equals, I've seen marks equals to -1, break. And then again, total I'm calculating here, sum equals sum plus marks. So try these in your compiler, just type them out and see how they work. Change a little bit somewhere and then see how do they work. Now the continue statement is similar to break, but with a very subtle difference and very important difference. The continue statement, when it is executed in any of these loops, they skip the remaining statements in the body of that loop and proceed with the next iteration. Now that's the important part. A break takes you completely out of the body of the loop and it comes out of that for loop or a while loop. But a continuous statement will only skip the rest of the statements in the body and it will continue with the next value of the iteration, next value of the updation. So in a while and do while statement, the loop continuation condition is evaluated immediately after the continuous statement executes. In the for statement, what it does, the updation expression will execute or the increment expression will execute, and then the loop continuation test will be evaluated. And the syntax is straightforward. Continue with a semicolon mark. Example is given here. So I say in int number sum, I initialize these two things as 0 and see how it is enter the numbers. So computer will ask you to enter a few numbers and I have a do while loop here. So do see in number, at least one number I have to input. So I input this number. If this number is equal to 0, then break. then it will just come out here. If it will come out here. If it is less than 0, then continue. Suppose you put -1 by mistake. Continue means then it will come here at the condition while 1, and because 1 is true, so it goes back until number becomes 0, because then only it will break. Otherwise it will keep on continue. If it is less than 0, see what is the next statement. If it is positive, then it will calculate the sum equals sum plus number. But if you by mistake give a negative number, it will not go to this particular. Since it is continue, it will skip the rest of the statement, which is one statement here, and directly go to the while statement here. It will skip that. If number is greater than 0, of course, then it will calculate the total sum as a current total with the number which is inputted here. So continue will skip this portion and go back here, go back to the do statement. If for a break statement, it will skip all the statements, including this statement also. It will come here. Break will exit the loop. Continue will continue within the loop, skipping rest of the statements. So that is a summary of this. Now, the last control statement I would be discussing in this lecture series will be a go-to statement. If it is a very, very convenient statement, but very, very bad statement, I would say, I will not ask you to use this statement, but sometimes when you cannot do anything, then you use go-to statement. Go-to is it also alters the flow of control in a program, and normally not recommended because it makes a chaotic situation in the program. Because go-to is you give your all your statements. If you give a number to them, if you give a label to them, and you just say anywhere in the program, go to that label, so it will immediately go to that particular label without checking any conditions. So it's not an elegant statement. However, it will work. So when a goto statement is executed in a program, the control of flow jumps directly to a specified location, which is specified by a label within the statement. And the syntax is go to label. Label is any label given by you to a particular statement. Label is simply an identifier which is given by you, followed by a colon placed in the front of a statement. The syntax is this go to label followed by semicolon. Like here, suppose I say here label. This label can be 10, 20, I can say X, Y, Z, anything. This is not a keyword, so you can give anything. It's not necessary that you have to call it a label, but it's just an example. You have a main program, you have a couple of integers, you enter the number, you input a number, you then your computer asks enter the divisor, you input a divisor, this is a numerator. Then you say if d is equal to 0, if denominator equals to 0, then you see out cannot divide by 0. Then you are saying go to label, which is this, and then you say since it is cannot divide by 0, end of program. So your program will not go to these statements, it will directly go to label. It will search for the label. This label can be either below this line or above this line, also anywhere. So it will just take you to that particular label. In this particular case, label is label colon cout end of program. If d is not equal to 0, then this portion will be skipped, and you will say that quotient is ny divided by d, and the remainder is n modulo d, and you get the answers for numerator divided by denominator. You will get these couple of answers. So that is how these go to statements are used, but I do not really prefer go to statement. You could have achieved that with a while or a do while loop also. So the next important thing after the control structures is one of the few important things is arrays. The arrays, what are arrays? Arrays are data structures which consist of all the related data items of the same type and which are addressed by a common name. Like if I give you an example of common life, I can say the class of ESN103. What is ESN103? So ESN103, let's say it's an array. It has 70 objects of type students. All of you are students, and you are attending class ESN 103. So I can, if I send an assignment to ESN 103, it will apply to all of you. So all of you will work out that assignment and give me back. So that is a concept of arrays, that when you club together all the data types of the similar type and you address them by a common name, it is called an array. And how this, if you look at the computer memory location, see, computer's memory location is always sort of a linear in nature. If I'll show you in the next slide very soon, and a little later in the course also, when we discuss the number systems and memories uh, manipulation, then you will see more about memory. It's very important to understand how the computer's memory work. All the items in an array are stored in contiguous memory locations. What does that mean? They are side by side. All of them are together. They are all stored together. So if suppose if there is an array defined of an integer type, and one integer takes about 4 bytes, and an array of 10 such elements are there in that integer array, then 4 multiplied by 10, there should be 40 bytes reserved for uh, for an array. As whenever I don't know if I told you earlier, whenever an object is defined in C++, when you define the data type, like when you say int a, float b, all these things are stored in the computer, immediately reserves a location in them in its memory for that particular variable. And whenever you change that variable, the new value of that variable is stored in that place of memory. So memory of a variable is fixed, uh, it has a fixed location. Similarly, arrays, there are several variables several variables of similar type are stored in that particular memory group. So all the items in an array, they are stored in contiguous memory locations. So therefore, what is an array? It's a consecutive group of memory locations which all have the same type. All of them may either be integer or floating point number or boolean or whatever, but they will all are the same type. So if you take an example, if I define arrays are defined like that, this is the syntax, the name of the array, and by in the square brackets, number of elements available in that array are placed here. So int marks brackets 10 means there are 10 elements in this array, which and it is called the array called marks. And then, like I told you, the example of the class ESN 103. So this is a class defined. How do I find out individual element of this class of your ESN 103? That will be I'll ask them by enrollment number or something. So similarly, there is an element number in the arrays with which you will define that particular. You will call that particular element. So int marks 10, it defines an array by the name marks which can hold a maximum of 10 elements. It can hold maximum of 10, but it can be less than 10 also. So maximum number I have defined here, that I am reserving a memory location in my computer for at the most 10 marks. An individual element in an array can be accessed by giving the name of the array followed by the position number of that particular element. If I say marks 4, then that particular element will be accessed. So instead of naming them differently, I just name them by the same name, but this element number, it's just like if you all know how the matrices are identified. Matrix has a one number, but depending on the rows and columns of that number, you can identify the individual element. So marks 4 means the fifth element will be identified. I'll tell you in a moment why fifth element. The position number is referred to as index or subscript. I can say it's a subscript of the array or index of the array. The first element in an array has the index 0. That is an important thing. This you have to remember. That is why I told you marks 4 means it is 1, 2, 3, 4, fifth element of the array. So basically marks n will be n minus marks n will be n plus 1th element of the array, because first element is always 0, marks 0, it is indicated by the index 0. These indices are predetermined, so you will always call this element as the name of the array 0, this is the name of the arrow bracket in the bracket 1, and so on. So the syntax for declaring an array is, you will say data type int, float, bool, char, anything, then the name of the array which is given by you, and then the maximum size of the array that is also given by you, depending on if you know how large is this array going to be. The index expression for an array may be either a constant or a variable name. So the index expression can also be a variable name, or it may be a combination of variable operators and function call. That means it can be arithmetic expression also. Functions you did not study yet, but you will very soon, probably in the next class, you will study the functions also. So you can have either a variable name or a constant or a combination of those in the expression part. So, but whatever is the form of expression, it must evaluate to an integer value. The outcome of this expression has to be an integer value. If you are using a variable name, then the value of this variable name should be an integer value. So that is what you should remember all the time. If a program uses an expression as an index, then the program evaluates the expression to determine that index. Marks a plus b, it will evaluate the value of a plus b, and that will be the index of that thing, where I'm saying marks a plus 3. So whatever is the marks at the place marks a, you add 3 to it and replace it at the place marks a plus b. So each array element is treated exactly as a individual variable. So you all guys are, let's say you all guys are variables, and then a collection of these variable is your a group of students, so that is a collection of that, but individually you are a variable. So exactly the same way as any simple variable of the corresponding type. So if you have an int array, then each member element of this array will be an of integer type. So you can do all those arithmetic you can run on individual elements always. So suppose I can say the third element of this marks array, marks 2, is 76. Then I say in the new marks 2, and or you can say x equals marks 2 upon 10.0. So you can carry out any of those operations on a uh, array element, individual element also. How do you initialize array in declarations? You initialize. You can give their initial values in the declaration itself. When you declare an array, suppose you're declaring an array int age. Age is an array which has at the most 5 elements. So I can leave it like that, so that later on I can input that. And if I know beforehand what is the value of these numbers, I can initialize them like that within curly brackets and separated by commas. So and this is an assignment operator. So I give 5 values 20, 23, 30, 10, and 33 to this array. Now this array is stored at consecutive memory locations in your computer. Now if you are initializing that, then it is not necessary to specify the size of the array while initializing. The computer will automatically calculate the size of the array. So if you are saying that there is a char array which is s, I didn't give the this thing, I didn't give the size of the array here, but I assigned these 3 values to that. So automatically this will be initialized as the array of 3 elements. So if you provide more initializer, the next point is, if you have suppose 5, you have defined as 5, but you initialize with 3 numbers, 6 numbers, then this this will be a compilation error. Your computer will say, oh, there is an error, you have only reserved 5 places for this array, but you have given 6 numbers here. That is not allowed. So if you provide more initializers in an array initialization, then the size of the array, that will be usually a compilation error. These are standard rules for array I am discussing. If this array is initialized at definition with fewer values, If you have more values, there will be an error. But if you suppose you have a less values, there are no further values given. In marks 5 equals 55, 77. Rest of the three values are not given. Then automatically these three values will be taken as 0. So the rule is, if you are partially initializing an array, all the values which are used in that order, first value corresponding to the first array element, second value corresponds to the second element, and so on. All the non-contiguous array elements cannot be initialized by skipping over the elements. I cannot say the size of the array must be defined at the compile time, right? So you cannot skip this, because they will always go into uh, I cannot say 55 comma blank comma 77. I cannot say that. And where I mean that this should be 55, this should be 0, this should be 77, no, that is not allowed. I will have to say 55 then comma 0 comma 77 if I want that particular element to be 0. How do we input or the array element? Individual array element can be inputted or displayed as ordinary variable, like what you do with any simple variable. Instead of saying a variable name, you are just calling that particular name. That maybe you can consider it, it's just like similar to your enrollment number, marks 4. So that is whatever guy is there enrolled with enrollment number 4, he or she will be called, and that will be used here. So C in marks 4, C out marks 3, etc. All these things can be done. How do you input or output several array elements? Then I can use loop. That is the most basic use of a loop. A for loop is always used to handle arrays. So like suppose you have 10 elements in an array, and you will say for I equals to 0 up to I is less than 10, and each time you go to I plus plus I, and C in marks I. So these 10 values will be inputted in sequence as you go along. Similarly, you can do it for output also. So these are similar statements. So all these loops are usually used for playing with array. Playing means when you are using array. Now, out of bound array indices, that is a very important thing. What is an out of bound array index? It is an index which is beyond the range of index values. Suppose you have defined my index values goes only up to 0 to 9, or you have 10 elements. So my index will go up to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These 10 values. So the range of index value is 0 to 9. If I use any index value which is either less than 0 or greater than 9, that is called a out of bound index. So if I have somewhere you call marks 11, that is not going to be accepted by your computer, there will be an error. But C++ does not support bound checking, so it does not check the validity of the array index while accessing the array element. So that may be a sort of a logical error or something like that. So when the program tries to store something beyond the size of the array, neither the compiler would know anything, nor the runtime. They will not indicate an array, but so these kind of errors are very difficult to handle. So you have to take care of them beforehand, and you have to, in general, they should be avoided because they will lead to logical errors. So you should not use anything out of bound. Now this is a program which uses an array of 100 elements, and it reads all the elements and then display all the elements. Very simple program, very basic program, but you will be using those kind of things in many of your programs. In fact, all of your program, when you use arrays, you will be using them. So you say C out how many numbers in the array, you will say, you will input them. Okay, I have 5 numbers. Then you enter the elements int I equals to 0, since you input n equals to 5, so n becomes 5 here. So you will 5 numbers you will input ai, a1, a0, a1, a2, a3, and a4. Then you see out contents of the array again 5 times. I equal to 0, I less than n, I plus plus, C out ai. This time all these elements what you inputted there, they will be displayed with a tab sign in a single line, with a tab differentiating between successive elements. So this is a simple program to read and display arrays. Now, suppose you want to find maximum value in a maximum value of the elements given in an array. Again, all the program are similar as you had earlier. Enter the elements. Now, up to this point, the program is same as the last one. Now, here you are finding out what is the maximum. So you assign the first element of the array as max, a number max, which is going to give you the final output as the maximum number. Then you do for I equals to 1. See, now you are not using element 0 here. I is equal to 1 up to I equal to n, up to the end of the array. And you are putting a condition. If max is less than ai, which is present value of ai, a1, a2, a3, a4 and so on, it is compared with this, then max equals to ai. That's what I'm doing. So wherever you find a greater number, automatically that greater number is assigned to max, and now within this new value of max, all these numbers are compared. So ultimately what will happen, you will get the maximum of all these numbers. So when you are finished with that, then you'll say see out the largest value in the array is max. And I think there's a mistake here. This see out statement should be outside of this curly bracket. Okay, that is a challenge to you again, and you should type out this program in your compiler and then check whether this cout, what happens if the cout is written here, and what happens if cout is written outside this loop. Okay, good challenge to you. Okay, go ahead.
So today we have just started learning about arrays, arrays which is a collection of or a group of similar objects grouped together. That's why they are called arrays. And how do we perform actions on different arrays? In the next class, we will discuss further on the similar topic. See you then.